So we are finally down to the last step in our derivation of the QG momentum equation. And that very last step will be to deal with the horizontal wind vector that is part of the Coriolis term on the right-hand side. Just as we've done with the acceleration term and with the horizontal advection term, we're going to break this horizontal wind vector into geostrophic and ageostrophic components in order to produce this. So the vector v becomes the sum of vg plus vag. And we can expand this Coriolis cross product here, recognizing that, again, the cross product is just a form of multiplication. So when we do that, for the first term here, we get a minus f naught k hat cross vg. For the second term, we get minus f naught k hat cross vag. For the third term, we get minus beta y k hat cross vg. And for the fourth term, we get minus beta y k hat cross vag. And the first two terms here now cancel in this equation to the right of the equal sign. And so we have three terms to deal with and to scale. And we'll apply the same scales that we have developed so far for the terms that we have. And so for the first term here, we have the product of two things. We have f naught scaled as f, and we have vag. For the second term, we have beta, we have y, which scales as L, and we have vg. And for the third term, we have beta again, y again, so beta times L times this time vag. And so we apply the scales in here to get our magnitudes. F is 10 to the minus 4, so 10 to the minus 4 times 1 is 10 to the minus 4. And here we have beta times L times Vg. Beta is 10 to the minus 11 times 10 to the 6th times 10 gives us an overall magnitude of 10 to the minus 4. And for the final term, beta 10 to the minus 11th times L 10 to the 6th times VAG 1 gives us an overall magnitude of 10 to the minus 5. So of the three remaining terms on the right-hand side, the third term is an order of magnitude smaller than the other two, suggesting that we can neglect it. And that leaves us with our acceleration term on the left. The acceleration of the horizontal geostrophic wind is equal to these two terms on the right-hand side. And this will represent the final vector form of our QG momentum equation after all of that scaling and all of the assumptions and simplifications that we have applied. So going back to our kind of master checklist of what we need to do to ultimately derive the QG height tendency and QG omega equations, we had already previously written down the simplified Eulerian momentum equations in isobaric coordinates. We combined those to a simplified vector momentum equation. We have partitioned that momentum equation into geostrophic and ageostrophic parts. We've applied the various scaling arguments and simplifications, and we now have written down the number 3 QG vector momentum equation. In the next part, we'll pause for a moment on that to take a look at the physical meaning of a couple of the terms in there. And then once we've done that, we'll go on to derive the QG vorticity equation.